Hello again everyone, welcome back to ptet.chemistry channel. So in this very last bit on this acid, bases and salt topic, we're going to be talking about water of crystallization. So it's a concept that you have come across when you were doing MR calculations, when you were doing gravimetric analysis back in year 9 mole calculations and stoichiometry. So basically, just to remind ourselves, hydrate ourselves means there is water. Hydrated salts that contain this thing called water of crystallization. So despite the term water there, is actually part of the crystals. So hydrated salts are actually solid because they are crystalline solid, because they have these water of crystallization present in the formula. Anhydrous salt is the one where you have driven out all the water of crystallization. They are no longer hydrated. They do not contain water of crystallization. So what is this water of crystallization actually? There are two particular case studies in the syllabus. So this is called hydrated copper 2 sulfate, because it's copper 2 plus with the sulfate there. This is called hydrated cobalt 2 chloride. So make sure that you know how to spell out the name properly. So write down the name of this substance, that is hydrated cobalt bracket 2, because that is the oxidation number of the cobalt there. If you think about cobalt, and then you have 2 of the chloride, each of the chlorine there is chloride, so it's a -1 charge. We're looking just at the COCl2 without looking at the water, because the water is a neutral molecule, so it doesn't have any charge. So the oxidation state of the H2O is definitely 0. It won't have an effect on the oxidation state of the COCl2. Overall, for the COCl2, it's just 0. This is overall oxidation number for just the compound. Ionic compound is a compound with 0 oxidation number. So cobalt there is just +2. Whereas for this copper 2 sulfate, you have Cu, and then you have the -2 for the charge of the sulfate, because you have 1 of the sulfate, so you just have copper +2. So that -2 is the charge of the anion, so it's the charge of the SO4 2-. That is why the oxidation number of the ion is the charge of the ion, straight from year 9 redox topic. This is called hydrated copper 2 sulfate. If you are asked to write on anhydrous copper 2 sulfate, then you just write CuSO4 without the water crystallization. Now the very next example is just on a different non-transition metal. Even though they are not in the syllabus, this is magnesium sulfate. It has got water of crystallization, is hydrated, then they become anhydrous, and they give you the water of crystallization. All of them have been driven out. As I did mention, these are part of year 9 gravimetric analysis. You heat until constant mass. So you heat until constant mass because you want to ensure, you want to make certain that all the water of crystallization have been driven out. When there is no further water to be driven out, this mass will remain constant. Of course, this is inside a test tube, so you have like mass of test tube, and then mass of this inside a test tube after you heat it, mass of this inside a test tube before you heat it. Of course, you could also use other apparatus. Instead of a test tube or boiling tube, you could use something called crucible, something you had used when we did gravimetric analysis experiment last year. This symbol there, delta, it simply referred to heat. This reaction is basically kind of like, it's not really thermal decomposition, because you're not decomposing, you're just removing the heat, the water crystallization. This is just the presence of heat there. So the first thing you will notice is this thing here, colorless liquid condenses on the upper part of the tube. You might think that this is not transition metal, so you get colorless liquid because you might think it's white solid. However, the exact same observation is also seen with CuSO4.5H2O. So this is a blue solid. This is a blue solid, blue crystals. You heat it, so you heat it, and then you get CuSO4. Not aqueous, because you don't add any water, so that is blue solid, and this is a white solid. So hydrated copper 2 sulfate is blue, but anhydrous copper 2 sulfate is white in color, and you will get 5H2O, and this will be given out not just as liquid water. In fact, you do release it as liquid water, but the temperature is very high that it will turn to steam, and which is why it will condense back on the upper part of the tube, which is a bit colder. So colorless liquid forms on the upper part of the tube, you do not see water. Instead, you see a colorless liquid, which is essentially the water. So even though you start from a blue solid, you still get a colorless liquid because the water crystallizations will give you the colorless liquid on the colder, the slightly cooler end of the tube there. So the test for water vapor, make sure you can use a white solid. This is anhydrous copper to sulfate. It will turn blue. Okay, so I have done that incorrectly. That shouldn't be blue solutions. So I'll be very oh yeah, that one is fine. Because in the presence of water, that should turn blue. Okay.
Transition metals they form, very special about them, they form colored compounds. If you get colored complexes that contains metal cations, colored complexes that contains or colored compounds that contain metal cations, most likely it contains transition metal. Transition metal is that region in the periodic table. You know, that's middle region. Those are the transition metal series. And copper is Cu, is just there. This is copper to sulfate, blue color crystals. You might have done crystallization of these. This is copper to sulfate, pentahydrate. If you look carefully, copper to sulfate, they don't say it's hydrated, but if you look at the formula, CuSO4.5H2O. I think I'm just going to do the example here to show you again how to calculate the relative molecular mass. So we have copper 2 plus because it's copper 2 sulfate. So 1 copper, so 1 times 64 plus 1 times 32 for the sulfur plus 4 times 16 for the oxygen. And then the dot simply means in the giant ionic lattice of copper to sulfate, which is an ionic compound, cations, anion, copper 2 plus, SO4 2 minus. I have 5 water crystallization, so 5 times 2 times 1 plus 16 times 1, or you know the molecular mass of water because of 2 hydrogen and 1 oxygen atom is 18 or 18.0. So altogether I have these Mr for the copper to sulfate plus the Mr for the water times by how many water crystallization. 64 times 1 plus 32 times 1 plus 16 times 4, I get 160. And then I have 5 water crystallization, so 5 times 18, that's 90. And I get 250 to the nearest whole number. If you look at these are the more accurate molecular mass. Not sure how clear it is. 5H2O, the molecular weight is close to 250. I think it's 249 point something because they are using a more accurate relative atomic masses. Okay, cobalt chloride with the water H2O. It was this color. So this is already a very old sample, the test paper. That's why you have this thing turning pink, because the water vapor in the air already turned all the supposedly blue, should have been blue. Okay. What I'll do instead is I will show you by heating this letter. I remove all the water of crystallization and then it will become blue. Because once I remove all the water, I only have the thing there that will become blue, and that is actually what is used to test for water vapor. That is, it will become blue, and they actually use it to coat the filter paper. And when you have water in contact with the cobalt to chloride blue colored thing, and then it will turn pink again because it will form the hydrated compound. On a copper 2 sulfate, hydrated, this is copper 2 sulfate with 5H2O. So this is a blue color solid, as I've shown you, very, very crystalline, like that. I will just take a little bit out, Go away. Really should have goggles and safety glasses and my lab coat. This is a blue color solid, as you can see, very crystalline. You can hear the sound. It doesn't stick on the walls of the thing because it's dry. When your test tube is dry, it should not have any solids stuck on the side at all. The upper part is dry, the lower part is dry. Okay, this was copper 2 sulfate with 5 water of crystallization, which of course you know how to calculate the molecular mass already. That was one of the earlier exercise. Okay, in qualitative analysis, they like to ask you to work out the identity of the cations and stuff. In A levels, they like to ask you the case study of copper 2 plus and cobalt 2 plus among many other transition metals. But here I'm just showing you the water crystallization will come off first when you do thermal decomposition. If it does decompose, the water crystallization always come off first, alright? So because water boils at 100 degrees Celsius. Bunsen burner, 100 degrees Celsius, very easy to reach when you have the blue color flame. So let's start heating. So just bring attention to this. You could see that the blue color solid has slowly turned white. So there's a bit of white solid now. And then there is a condensation, and this condensation is not colored, it's not blue in color. As you could see, it is a colorless liquid. These are liquid, these are not gas because they condenses on the upper part of the tube. I touch it outside and doesn't do anything because the liquid is actually inside. Because your water vapor was inside, if the steam was inside, it condenses on the upper part of the tube because the compound has water of crystallization. This is what you see. You see a colorless liquid form on the upper part of the tube. This is also what you see. The blue solid has turned white. I will heat it more strongly to get rid of all the water of crystallization, and hopefully it should make more sense in a little bit. The fire is not that strong. So I'm heating it a bit strongly now. And as I heat it more strongly, then all the water of crystallization will be driven off. Here it's very easy because you can see the color change. Whereas for the white colored solid, it's very difficult to tell, right? If you have gotten rid of all the water or not. Okay. So here you can tell that they already turned whitish. And they're already kind of stuck on the side, so I do not want to heat it even more strongly because I'm heating using a test tube and I do not want to break my test tubes, okay? So that was the copper 2 sulfate hydrated. The blue solid has gone. The blue solid, oh no, where am I, right? There was a copper 2, this was the copper 2 that give you the white color solid. Alright, so copper 2 sulfate hydrated. This was the hydrated salt that I heated just now. Remember, we started with very blue colored solid, very blue colored crystals. That was hydrated. In the absence of the water crystallization, the upper part of the tube is just water. In the absence of water, because I heated very strongly, you don't see any blue colored solid at all. They are all white colored solid. And because there's anhydrous, and I do actually have copper 2 sulfate anhydrous. Anhydrous means no water of crystallization. And let me look at the molecular mass. You see they only label it as CuSO4 because that is without the water of crystallization. It's a bit bluish, probably because this has been around for a long time, so it's absorbed a little bit of water from the atmosphere. But if it was freshly heated like this to remove the water crystallization, it would have been white. Okay, and I'm just going to add water to this anhydrous copper 2 sulfate. What do you notice? Alright, what do you notice? So they can ask you this in a qualitative analysis experiment, not just in O level, but most likely in A level, I guess, where they give you a blue color solid, they ask you to heat it, and then you see colorless liquid fall on the upper part of the tube, the blue solid goes white. Okay, you heat strongly until it goes white, that's the observations, and then you add water to it after it cools down, and you get a blue solution again. The fact that you get a blue solution again, okay, refers to this idea of reversible reactions. In the presence of water, the anhydrous copper 2 sulfate gets surrounded by water molecules again, and they reform that hydrated compound, okay, which you can then purify by crystallization, or better hold it tightly, purify by crystallization, and you can get the hydrated crystals where the water as the solvent can co-crystallize, meaning they crystallize together with the giant ionic structure of copper 2 sulfate.
Whereas in the presence of water, the blue solid will turn pink. The white solid will turn blue because there is copper 2 sulfate anhydrous become copper 2 sulfate hydrated, which then dissolve in water to give you the Cu2 plus aqueous. The cobalt chloride, the cobalt 2 chloride anhydrous become the pink solution from blue to pink. Make sure you write the charge of the ion correctly. I have done that mistake there. Okay, so just in terms of the observations, these reactions are reversible. Reversible means they can go both way. So you have learned that in the sense of partial dissociation of weak acid into H+. This is not partial dissociation into weak acid. This is just reversible. You can go from left to right. You can go from right back to left. These are the important color changes. Make sure that you know about these color changes as the syllabus does require you to do that. The hydrated copper 2 sulfate is blue. It goes to white when you remove all the water crystallization. This with 6 water of crystallization is pink. Hydrated cobalt 2 chloride is pink, and then it becomes blue. So typically we would use the blue anhydrous cobalt 2 chloride to test for water vapor. In the presence of water vapor, this becomes hydrated, and then it will form the pink solid from blue to pink. If you have copper 2 sulfate solid, in the presence of water, they will become hydrated. It will go from white to blue there. Okay, so hopefully that makes sense. In between this, I'll append in some experimental tutorial video showing you these particular color changes. And apart from that, yeah, I mean, that's it really. Compared to the test tube, so this is a pink solid. We will heat it. If I heat the pink solid, it's a hydrated salt. So first thing that comes off will be the water of crystallization. How you can see now it is blue, just now was pink. There's a bit of condensation on the upper part of the tube, and if I heat it further, it will become more obvious. It's the water crystallization that is coming off. So the water crystallization is coming off, you get a colorless liquid formed on the upper part of the tube. Hot end, cold end, water crystallization escape as steam, and when they reach the cold end, they will condense. You get a colorless liquid. This was a colored compound, so it all makes sense hopefully. So hydrated cobalt 2 chloride was pink in color, and this is what you call, this blue color is what you call anhydrous. Anhydrous because you remove the water crystallization and it's blue. So what happened with this blue color solution is, if I add water to it, it will become hydrated again, and we use anhydrous cobalt 2 chloride paper, which is filter paper coated with this anhydrous cobalt 2 chloride to test for water vapor or water, and it will turn pink. I'll wait for a bit until it cools down before I add water to this hot glass test tube. It's very dangerous to add water to a hot glass test tube, okay? So I think my test tube has already cooled down. Remember, I had the hydrated cobalt 2 chloride, which was pink, and also pink in solution. Now this was the heated one. Some of it has turned a bit pinkish because of the water vapor in the atmosphere. So this is cool now. I can add distilled water to the blue color solid, which was supposed to be anhydrous, because I drive off the water crystallization. And you notice that the solution again is pink, because in the presence of water, it gets hydrated again. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. I'll see you in the next tutorial video. And this is practically the end of these acid, bases, and salt series of tutorial videos.